What we're going to do is just go over a quick review of some of the terminology and ideas around solutions in preparation for class the next day. Remember, solutions are a homogeneous mixture that consists of one phase, meaning that they're uniform throughout. Okay, a solution has two parts. It has a solute, which is a substance that is dissolved. Usually it's a substance present in the lower amount. And our solvent, the medium that does the dissolving, often a liquid, usually the thing present in a greater amount. Okay, now a lot of the solutions that we talk about are aqueous solutions, where water is my solvent. And the reason that we look at aqueous solutions so much is water is one of the few solvents that can dissolve both salts, or ionic compounds, and organic compounds, or carbon-containing compounds. Okay, and also remember we talked about in class that they can be divided into an electrolyte or non-electrolyte, which are solutions that will conduct electricity, and the substances that cause me to or result in electrolyte are ionic solutions, acidic solutions, or basic solutions. What we talked about being able to rank substances in terms of their solubility. In particular, we looked at their solubility in water. Now, remember when we talked about whether or not a solute could dissolve, we looked at it in terms of degree of attraction, and the attractions have to be equivalent or greater for a substance to dissolve. And if they're not, then the solute will not dissolve in the solvent. So let's take a look at the solubility of two compounds, ethane and ethanoic acid, in water. And we're going to see which one is more soluble using our ideas of attractions between solutes and solvents. So first off, what we want to do is remember we need to know what intermolecular attractions each of these compounds can form or will form. And to do that, we need to know its shape. So if we take these two molecules and we look at their shapes, we can see that my ethanoic acid has a carbon bonded to an oxygen, and a hydrogen bonded to an oxygen. And so now what we could do is we can look up our electronegativities, and we would see a polar bond here, a polar bond here, and we know we have a polar bond between our hydrogen and oxygen. Since I would have a pole here and a pole here that don't cancel out, this would be a polar molecule. And also I have a hydrogen bonded to an oxygen, which means that it will have hydrogen bonding. Whereas this molecule only has carbons and hydrogens, and since the electronegativity is such that there are no polar bonds, we'll know that this is a nonpolar molecule. Therefore, we can see the intermolecular forces that will form between ethanoic acid molecules, London dispersion forces, because they form between everything. Since this is a polar molecule, they will have dipole-dipole attractions, and because they have a hydrogen bonded to an oxygen, it will be able to form hydrogen bonding with itself. This molecule, because it's nonpolar, the ethane can only form London forces with itself. As a result, if we look at the intermolecular forces between our particles in water, we'll have London force, because they're between everything. Both water and my ethanoic acid are polar molecules, so I'll have dipole-dipole attractions. And also because both water and ethanoic acid can form and receive hydrogen bonding, I have two-way hydrogen bonding. Whereas this nonpolar molecule will only form London dispersion forces with water. So as a result, we would say that my ethane has low solubility while my ethanoic acid has high. Remember, when we want to give our explanation, we want to explain it in terms of the degree of attraction. So since my ethanoic acid forms equivalent attractions with itself, London force, dipole-dipole, hydrogen bonding, as it forms with water, London force, dipole-dipole, hydrogen bonding, and the same goes for water, it will be soluble because the attractions are equivalent or greater between the two particles. Whereas water is more attracted to itself, London force, dipole-dipole, and hydrogen bonding with itself, compared to the weak London forces it forms with the ethane. Since it has only weak London forces with the ethane, its ethane is not going to be very attracted to water, and so as a result, it will have low solubility.